Hello and welcome back. We will start section 2.4 in this video, which is on slope again. So this is looking at a few uses for the slope. So the first thing that we'll look at are parallel lines. And parallel lines, as I've drawn down here, are lines that will never meet. Essentially, they're essentially pointing in the same direction. They're just off by a little bit. But because they're pointing in the same direction, they will always stay the same distance apart the whole way as you travel along these lines. So non-vertical lines are parallel when they have the same slope. So both of these lines will have the same slope. And we'll look at what their slopes are in a second. But when we think about vertical lines, the slope for a vertical line is undefined. So we can't exactly say that these have the same slope, but we can see that they're clearly parallel. If they're both pointing straight up, then they should be parallel. So what we want is for parallel lines to have the same slope. Let's go through and actually calculate what the slopes here are. The first line up here passes through the point -2, 0, and through the point that looks like 0, 1. So let's find the slope. So then I'll take the difference of the y values, 1 minus 0, over the difference of the x values, 0 minus -2, and we get 1/2. 1 divided by 2. So this is the first one. And then the second line over here, this passes through the point 0, -1, and through the point 2, 0. So let's find this slope. We'll take the difference of the y values. So we'll take 0 minus a -1 divided by 2 minus 0, and we see that we get 1/2 again. So they have the same slope. If we want to write down an equation for these two guys, we can use the slope-intercept form, where this is going to be y is equal to the slope times x plus the intercept. So for this line, the intercept is going to be 1, and we're talking about the y-intercept here. So this is the y-intercept. For this one, again, we'll look at this equation, and this will be y is equal to 1/2 x, again, the slope, plus the intercept. Well, the intercept here, we're intersecting the y-axis below the x-axis, so this is going to be a negative number, so we'll subtract 1, and this is going to be the y-intercept again. So you can see that both of these have very similar equations. The slope is the same in both. For vertical lines, the slope is undefined, but both of their slopes are undefined and they're both vertical, so we can see that these are parallel. If we wrote down these equations, the equation for a vertical line is going to be x is equal to, and then whatever that x value is. So here x is equal to 2 for the first one, and x is equal to 4 for the second one. In both of these, it doesn't matter what y is. You can plug in y is any value you want, but we see that the x value is always the same. It's not moving any to the left or right. So just some examples of parallel lines given by equations. So here we can find the equation of a line passing through this point, and it must be parallel to this line. Well, lines are parallel if they have the same slope. So we know that the slope of this line must be 3. So the parallel line if I write this in point slope form, I'm going to say y, let me just write the equation, y minus y1 is equal to m times x minus x1, where x1, y1 is going to be the point that we're passing through, and m is the slope. Well, we have all this information. Our slope is going to be 3, and then when we have x minus x1, well, this is going to be x minus -2, which will turn into +2, and y is going to be 5. So we'll have y minus 5. So this is point slope form. But maybe we prefer slope intercept form. It's a perfectly valid way to write an equation. So let's simplify this. Y minus 5, and then we'll have 3x. Multiply this across to get 6. And then if I add 5 to both sides, I'll get y is equal to 3x plus 11. And this is going to be slope intercept form. So both of these equations are perfectly valid, and we'll just use whichever one is easier at the time. Point slope form is nice because if you're given the slope, as in we know that it must be parallel, and we're given a point, it's really easy to write this down. So if we're going to talk about parallel lines, we can also talk about perpendicular lines. And perpendicular means that the lines are going to be passing at right angles to one another. So here are two lines in this graph, and they are passing at right angles to one another. So these are going to be perpendicular. One nice thing is that all of these angles are all going to be right angles, meaning 90 degrees. So generally we'll just mark one of them. So again, here are some that are meant to be at right angles. Maybe I've drawn this a little bit incorrectly, but these are also going to be perpendicular to one another. They intersect at right angles. So unlike parallel lines, which have the same slope, perpendicular lines have a slightly more complicated way of describing their slopes. When you take the product of their slopes, you get -1. Now this only works if your line has a slope. So when you have a vertical line, the slope is undefined, so we can't really take its product. But we can see that a vertical line is going to be perpendicular to any horizontal line. So when we're looking at lines that aren't straight up and down or straight left and right, the product of their slopes is going to be -1. And I'll briefly go through why this is. If we look at the slope here, I can draw a little triangle where we have the rise, how far it goes up, divided by the run. And let me give these names. Let's call the rise C, and we'll call the run D. So for this line here, the slope is going to be the rise over the run, C over D. Now, if I rotate this 90 degrees, this triangle, we can see will go to about right here. And what was the rise is now turned into the run. And instead of going straight up, we're going backwards. So it'll be -C. And instead of going forward D, now we're going to go up D. So the slope of the new line is going to be the rise, which is now D, over the run, which is -C. And rather than writing it as D over -C, I'm just going to write it as, I'm going to pull out that negative sign and write it -D over C. And the trick here is, if you multiply these two numbers, what happens when I multiply C over D times -D over C? Well, I can pull out that negative sign, and then I'll have C over D times D over C, and we get cancel, 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 -1. So when we look at these two fractions, one easy way to remember the one easy way to remember perpendicular lines is that you take the reciprocal of the slope and you multiply it by -1. So let's try that with an example. So let's find the slope of any line perpendicular to this guy. So we have an equation of a line. We want to know the slope of a line that's perpendicular to it. So let's find the slope of this guy so that we can take the negative reciprocal. So I'm going to take this guy and I'm going to rewrite it in a form where I can read off the slope. So here's the line. here's the equation of the line. I'm going to get y by itself. So I'm going to add 12 to both sides, and I'm going to subtract x from both sides. So I'll just be left with a 3y is equal to, and then I have a minus x on this side, and a plus 12. And then I need to divide everything by 3, and I'll get y is equal to negative 1/3 x plus 4. So my slope in red is negative 1/3. So the slope of any line perpendicular to this, so the perpendicular slope is going to be the negative reciprocal. So we take the reciprocal of this, so instead of 1/3, it will be 3/1, and I want to negate this. So instead of, so I'm going to add an extra negative sign, but when you take the negative of negative, you just get positive, and 3 divided by 1 is 3. So the negative reciprocal of 1/3 is going to be 3 itself. So we now have the slope, and if we want to find the equation of a line perpendicular to this guy, well, we know it has to have slope 3, and if it's passing through this point, well, we've got a formula for that. We'll take y minus the y coordinate is equal to the slope times x minus the x coordinate. Simplifying this, we get y plus 6 is equal to 3 times x plus 2. So again, this is point slope form, which is great, but maybe we want it in a different form. So if we solve for y, we can get y is equal to, if I subtract 6 from both sides and distribute the 3, I get y is equal to 3x plus 6 minus 6. So y is equal to 3x. So this line here is going to be perpendicular to this line, and it passes through the point -2, -6. So again, everything is just, once you figure out the slope, if you're perpendicular or parallel, if you're parallel, you take the same slope. If you're perpendicular, you take the negative reciprocal. And when you know what point you need to pass through, you can just use point slope form. Once you have point slope form, you can put it into slope intercept form if you want, or especially if the homework asks for it. For this last one, we'll do a couple of examples where we're looking at horizontal or vertical lines, because these are slightly different. So find the equation of the line parallel to y is equal to 1 passing through 2, 3. I think for this one, it's easiest to draw a picture, and we'll be able to work this out pretty easily. So let's go 1, 2, 3, 4, 1, 2, 3, 4. So our line is y is equal to 1. So when the height is equal to 1, we just have the line that's going to be at height 1 all the way across. So it's a horizontal line. And we want the equation of a line parallel to this passing through 2, 3. So 1, 2, 1, 2, 3. So what does it mean to be parallel? It should follow the same, it should have the same slope. So it should be pointing in the same direction. So our original line was y is equal to 1. This line up here has a constant height the whole way. Well, that constant height is going to be 1, 2, 3. So this is the answer to, if I call this part A, this will be the answer to part A. If we look at part B, find the equation of the line perpendicular to y is equal to 1. Well, if we have our original equation is horizontal, a perpendicular line is going to be going up and down. And if it's passing through that same point, it's going to be just like this. And again, the equation of this line, the x value is always 2. The height changes, so x will be equal to 2 for the answer to part B.